Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We've been looking at various sorts in the recent videos. In the last video we saw how we could verify that our sorts were working, and in this video I want us to visualize the sorts. So when we were talking about the sorts themselves, I went through and I showed you how things move around, and that works for a small example. But it can be helpful to understand sorts, to actually see them working kind of in the large. And there are lots of sorting visualizations out there. You could go and do some searches for them. I actually want us to write our own, and in part because we can. Because we've done graphics. We know how to pop up a GUI and display stuff that we want in there. So I would like to have us actually write some code to do some visualization of sorts. And I want to start off by copying the code that we had last time over to a new file, because we're going to need to put some extra stuff in here, and I don't need the verification code. We are going to wind up having to change the sorts to get it so that they do what we want. And let's come in here and let's put our imports. Import swing._, import event._, import java.awt.color, import java.awt.geom._, import java.awt.image.bufferedImage. That should be sufficient for us. And the way I want to draw this is I want to have kind of a stack of 3 frames, and I want to make 3 different images for our 3 sorts. So val images. I really don't care too much about these, about the exact nature of these. So I'm going to, as far as how they're stored, I don't care if it's an array or a list or whatever. I'm perfectly fine with whatever Scala decides to pick. So inside of here, I am going to make a buffered image. New buffered image. How big should these be? Well, I'm going to go for, I don't know. Actually, let's go ahead and let's say val thumb values is equal to args sub 0.toInt, so that the user can tell us how many numbers they want to sort. And so I'm going to use that as my x size. My y size, I'm going to make these 200 so that they're not too tall and they fit in the display, because I'm going to stack them vertically. And I will use my preferred image type in there. In addition to knowing how many values there are, I'm going to create a new array, and actually array values will be I want this to be an array itself, so array.fill of 3 values, and each one of these is going to do I want a copy of the same set of values. Yeah, I kind of need to make one my original up front. Nums equals array.fill of num values math.random. And then inside of here I want to basically make a copy of nums, and so I guess I could do nums.map of xrocket x. That would definitely, it's one way of making a copy of an array. Because I want to kind of put the three sorts on an even footing, I want you to be able to see what happens to the three sorts when they're working on identical values. Get rid of that code there. And I just want to make sure I don't have any typos in that. Okay, in fact, so there were no typos. The error is because I didn't tell it a number, and it uses that right here. I guess we could, ideally we would want to put in something. If args.length is less than 1, print line. Actually, how about we do this? Just give it a default value. If args.length is less than 1, I'm going to make the default value 300, otherwise we can specify something else. I have my images, I have the sorts down here, and we'll have to go play with those in a bit. I want to make a panel that does its own painting, and all it's going to do is it's going to paint the three images in there. So override def paint, and g dot draw image, x is of 0 at the top, y is 0. Actually, for I in images dot indices, g dot draw image at x of 0, the y value is going to be I times 200, and whoops, I need the image first, which is images sub I, and all of these will use a null image observer. Okay, so the 4 images that we have will come down here. Trying to decide if I want to have those images rendered before or after, or inside of here or not. Right now I'm fine with doing not. This will just paint the images. Def render values. So this is going to be a function that I'm going to call, and I'm going to pass it the array that I want to render. And I want to pass it kind of 2 markers. And it turns out these markers aren't, let's go ahead and also say so I'm going to pass in the buffered image we're rendering to, an array that is of doubles, and then 2 markers. I can call them, I guess, I and j, sure. Actually, I'll call one j, because that's actually the loop variable. This one will be showing us kind of the inner loop variable, and the other one will be min, which is also an int. Now most of the time we're not going to use min, so I'll give it a default value. Once again, let's come over here and let's make sure that our code, I haven't had put any typos in. Okay. So what I want this to do is first, let's go ahead and create the graphics. For that, set the paint on it to black. We're going to fill in a new rectangle 2D dot double. And have it fill in the entire image. I'm going to set the paint to some other color, whatever color I want my lines to be drawn in. How about I do, I guess I can make my data be white. And then I want to run through a for loop that goes through all of the indices of the array, and for each one of these, g.draw a new line 2D dot double. The x value is simply I, and then there will be a y value, and then there will be another x value. The first y value is going to be 200, so we start at the bottom, and then however long it is depends upon how big the value of a is. So 200 minus 200 times ARR, actually I'm going to make this 190. So I leave kind of a gap of 10 at the top, and that will be beneficial for two things. So then I want to set paint. I want two other colors in here. How about a red? And for this, we're going to draw another line. And this line is going to indicate the j value. So the x is going to be a j. And then the y, well, this one's going to start at the top at 0 and just go down 10 pixels. I'm going to copy those two lines and then have the min value drawn in blue. If we render an image, we should tell the panel to repaint. Let's see if I have any typos yet. Indeed I do. Line 27, and it looks like I've left out a closed parentheses up here, and that could be propagating through to do lots of other stuff, but not in this case. Line 30, another exact same thing, left out a closed parentheses. Line 33, did I just do this all over the place? Apparently I did. Wow, that's really impressive for getting a parentheses. I have to say, I generally am not quite that bad. Times ARR, insert sub I. Okay, so this runs. We have a panel which draws some images. We have a function that will render images for us. And at the bottom here, let's make our panel so it has the right preferred size. Preferred size equals new dimension of, well, how big do I want this to be? Num values is my width, and 600 will be my height. Okay, we'll come down to the bottom here. Frame equals new main frame. Remember to open it. Okay, so I have a frame and I give it the panel and I open it, and if we run this now, it opened way over to the side. I'll need to do a center on screen so that you guys can see it better. But of course it doesn't do anything yet because I'm not actually calling my sorts at this time. And we can fix that. I actually want to call, so I have my three my three arrays values up here. So I want to call bubble sort on values sub 0. Min sort. And insertion sort. And this will be on value sub 1, and this will be on value sub 2. And now the problem is I want these to kind of all happen at the same time, and we haven't learned how to do that, but I will try and I could have, this doesn't work so well for a timer either to go through and do this. I have to go to a topic that we haven't really talked about, and I think in most ways I'm fine with that. First error, line 7. And yeah, and then I don't need what I'm doing here. So this is multi-threading. We had actually briefly hit upon this in the in an earlier video when we talked about parallel for loops. The main thing is that I want all three of these sorts to be happening at the same time, and I wasn't doing that earlier. Okay, so each one of these needs to be calling render values on its image and passing its array. So we take an image, an array, a j, and a min. In the case of bubble sort, I don't really care about the j and the min, and I'm going to draw it. Oops, this is one of those places where well, okay, I can. Let's do this. Render values, and my bubble sort is using images sub-0. If I wanted, I could pass in the image up here so that we could swap things around, but I'm really not going to worry about that too much. I want it to render array, and I want it to display the j value, and I don't care about the min value. Okay. That seems fine to me. The other thing that I want to do in here and that might be a little too slow. Yeah, I should probably speed that up a little bit. What I want to do is I want to make it pause for a while. So after it does the rendering, because you saw there was this really bad flicker and whatnot that's happening if we try to draw this at full speed. So what about for our min sort? Well, I'm also going to put this inside of the innermost loop, but here I do want to draw the min. We're rendering image into image 1 here. And let's see if that gives me the effect that I want. So here you can see there are two markers. This blue one is keeping track of the min, and so every so often it jumps, and the red one is keeping track of j. And our insertion sort, I put the code inside of the inner loop. Okay. And we go. Okay. So this code, now you can see the sorts working. The bubble sort and the selection sort are pretty much doing the same thing, except the bubble sort is moving stuff around as it goes, and the selection sort is just looking for a blue. It's finding the minimum, And then when it's done, that one value swaps to the front. The bubble sort, you can see, is kind of pushing values back as it goes, and so each time it gets to the back, it's pushed a new long bar back there. And then there's the insertion sort. And the insertion sort is clearly very different from the other two. It goes and it grabs a new value and it pushes it forward to the place where it belongs. And so when it grabs a short bar, it walks way up to the front. When it grabs a long bar, it might not hardly move at all. And so you can see that the insertion sort winds up getting a fair bit of the array very nicely sorted very quickly. However, the insertion sort slows down as you go, whereas the bubble sort and the selection sort speed up. I'm not going to have this video go all the way until these are done. I guess we could do these on a smaller set of numbers, just 100 instead of 300, and then we'd have a chance to actually potentially see them complete. And so you can see, now note that the bubble sort actually, as it goes, it gets things toward sorted because all the smaller things keep advancing forward one step at a time and the big things are pushed to the back. The min sort really doesn't change much of anything in here. It doesn't do any type of partial sorting on the main data. It's just moving things up to the front as it gets to them. And the insertion sort is building this sorted stuff up at the front, but it doesn't even touch the stuff that's at the end until it's ready to get there. Based on what you can see already, you can tell insertion sort is going to win this race. And remember, these are both all three of these are rendering every time through the inner loop. So this is at least a reasonably fair comparison of how many times they execute their inner loops. And our insertion sort looks like it has about 2 more things to move, and then it's done, and it's going to sit there. For random data, you actually expect the insertion sort to run twice as fast as the other two. And the reason is because on average it only has to push things forward halfway through the array. Sometimes it'll push them all the way to the end, but sometimes they won't go anywhere. So on average the insertion sort does half as many comparisons as the other two. Now of course this is redrawing at comparisons. If I were to change it so that it does render values on swaps, then the selection sort here in the middle would wind up winning, because it wouldn't show you all the comparisons it was doing. It would only show you and pause every time that it actually did a swap, and it does very few swaps. You can also tell at this point that the selection sort and the insertion and the selection sort and the bubble sort are basically getting faster because they have smaller and smaller regions to cover. Because our bubble sort was not a flagged bubble sort, this is actually going to sit and get to a point where all the values are sorted, and you can see then it runs for a while. And note the bubble sort and the selection sort finished at about the same time, which is exactly what you would expect. So feel free to write this, play with it, go out and look for other visualizations. Make sure that you understand these sorts and how they work. And we'll come back in the next video and talk about how we can sort things other than just the straight